Hopefully, yes. Okay. All right. Let's get started. So welcome to OPC Day International 2023, and welcome to my presentation about extending OPC UA to the field. So in the 20-30 minutes, let's see how long it will take. I'm certainly not giving a technical presentation, so I'd really like to concentrate to show the big picture. What is the status quo of our initiative and what are the next steps, what is coming up. Nevertheless, I think it's good to quickly introduce what is the purpose of the initiative that we actually launched back in November 2018. So at that time, there was an agreement to extend OPC UA to cover additional use cases in factory and process automation. And as Stefan already mentioned, this includes certain requirements and application areas such as motion control, instrumentation, functional safety, real-time is very important, and deterministic transport as well. On the right-hand side, you see, let's say, a very rough sketch about the overall solution approach. As I said, I'm not going too much in technical details, but you can easily understand the approach, which is we are reusing the OPC UA framework with existing client server, pub sub, which is very important to have a, let's say, a very fast exchange of process data. We use the built-in security and some of the base models. So this is the foundation, so to say. And we are then extending, we are adding certain information models and device behaviors for the different controllers and field device types. And we also deal with offline engineering. We introduce device descriptions, what we call offline descriptors, to do also offline engineering. So this is what we are adding here with our specifications that are named OPC UA Field Exchange, OPC UAFX. And very important is that we leverage certain standards out of external organizations when it comes to underlying network protocols and physical layers. So this is where we link to external standards out of IETF and IEEE. And with regard to TSN, the IEC IEEE 6802, the TSN profile for industrial automation. You see on the left-hand side the 25 companies that are active and member in our steering committee of the project. But I'd like also to add the information that all the technical work is done by all the OPC Foundation members that are either active or more monitoring the activities. And you will see later the structure we have set up to deal with the various elements of our solution approach. With that, I'd quickly like to remind everyone, and for those that are new to the topic, explain that there was an early agreement to divide the initiative in two project phases. Project phase one, it's about the controller-to-controller use case. We are developing a controller profile for all the different types of controllers that you find in FAE and PA. So including PLCs, DCS systems, motion robot controllers, numerical controllers. So this is about the horizontal connectivity, exchanging process data, real-time, safety, and so on between controllers. And project phase two is then extending these concepts to cover also what we name controller to device, which is also including device to device. And this is when we then define the different concepts for the different field devices, including motion devices, for example, servo drives, frequency converters, field instruments, remote IOs, and whatever you have in the field. So what is the current status of our initiative with regard to the specifications that we generate? You see here the front pages of the 5 specification parts that we have been working on. They are named parts 80 to 84. And you see that we have been releasing, this is the green color here, 4 out of 5 specs back in November 2022. That was a major milestone 4 years after we launched our initiative. We even did a revision of the part 81, which is probably one of the key parts, as it's describing the information model and also the connectivity between different controllers. There we did a revision in January this year, and there is still one specification marked in yellow color. This is where we have, in the meantime, finalized a final draft. But at the moment, we still have to develop some conformance units that will be included in the part 84. So part 84 is actually the specification where we list all the mandatory and also optional features that a controller has to support. So we are intensively working now on finalizing the part 83 and the revision on the part 84 profiles. This will then undergo member review, and in, let's say, 3 months, latest 4 months, we will have then these specs also finalized and released. One important aspect that I already mentioned is functional safety, because this project was actually started even before we launched the FLC initiative. We already have 3 releases out. The first release was supporting client server, the release 1.05, then extending to PubSub support. And also November last year, we had a revision of the specification, which has the version number 1.05.02. In addition to this specification, we have created a test specification that is also, let's say, the foundation for developing a safety test tool. This is one of the ongoing development projects we have. And we have, in addition, a development project to get developed a safety stack that can be used in prototyping, but that can also be used in commercial products by companies interested not to develop their own stack, but reuse a common stack that we get developed. For both projects, we are a little behind the schedule. Original plan was to be ready Q2 this year, and this is already almost done, as you know. So the plan is that we have both projects be assessed and also be certified by the TÜV as a notified body in the Q3 this year. Even I said I'm not going too much in technical details, I included this one slide as I believe this is a very essential element of our solution approach. And even I will not be able to explain all the details on the slide, I can give you an understanding how we approach the idea to support all the different requirements and application areas we find in automation. And you see here the scalable networking concept that we developed and where we get the agreement by all the experts and by all the supporting companies, including all the major automation suppliers. We agreed to use UDP transport using IP best effort and using the base network access facet as a mandatory feature for all the UAFX controllers and later on the UAFX field devices. So this has to be supported by all the UAFX products that come to the market. Nevertheless, we have certain requirements that also need some further optimizations. And this is why you see here some optional features. On the one hand side, we find here the Ethernet UADP transport facet. This is directly mapping the OPC UA protocol, the encoding UADP, directly to layer 2. So it's not using UDP IP, and that enhances the performance and increases the efficiency that you need for, let's say, high performance automation applications. And And in addition, you then can combine this more, let's say, efficient mapping with an underlying TSN, which is then providing deterministic transport based on standard Ethernet. And also for TSN, we have come up with a scalable approach where we group certain features out of TSN in different facets, base, advanced, and full. So also there we have a scalability with regard to the quality of service. And with this concept, we can address all the needs of all the different device types and applications that I mentioned in factory automation, process automation, and even beyond. Another important element in the solution is that, and this is also good news, and we're actually proud of that, that we got an agreement by all the experts, by all the companies, and also including all the major automation suppliers in the world to exactly develop one controller profile and not various profiles. So we have exactly one controller profile as specified in Part 84, and this is covering all the different types of controllers, independent where the controller is being used. And in this overview, you see all the required facets out of UAFX. This is in the light blue. And out of UA specifications, this is the light orange here. And the only optional facet that we defined in this profile is the safety facet, because not all controllers are supporting functional safety and fail-safe communication. So this is good news because it provides a common foundation for really cross-company and cross-application connectivity horizontally between controllers. The Part 84 controller profile is also the basis in order to prepare conformance testing. And we took a very early decision in our initiative that the certification of UAFX controllers and devices will be mandatory. The reason is that certainly these devices supporting UAFX are being used in areas in the OT where it's really critical for the process and for the availability of the production. So we have to ensure high quality, and we have to ensure the best possible cross-vendor interoperability. To achieve this high quality, we have different developments going on. One development is related to the compliance test tool of OPC Foundation, the CTT. So we are creating test cases and test scripts for the CTT to allow the testing of UAFX implementations. Expectation is that we have these test scripts developed by end of the year, Q4 2023. There is then the other tool that I quickly mentioned before, talking about OPCUA safety. This is the OPCUA safety compliance test tool, which is complementary to the CTT. And this is already expected to be available in Q3 of this year. And the third aspect is that we also prepare for the testing and later on certification of products supporting the advanced physical layer. So we have in our European test lab tools to test APL. We have also some environment now to be ready for vendors providing first APL devices supporting OPCUA and in addition UAFX. In this context, I also like to mention two joint activities, one with some other standards developing organizations with regard to TSN. We have a joint activity to develop a common test specification for the IEC IEEE 6802, the common TSN profile for industrial automation. And we have a separate joint activity, which is the Ethernet APL maintenance collaboration. This is where we are jointly maintaining the APL specifications and the APL tools. And we also have started to discuss how to mutually recognize the certificates that have been issued by test labs that are assigned to one of the cooperating standards developing organizations. So this will mean that vendors need not retest their APL interfaces in different labs just because they are supporting different protocols. In this context, I'd like, even if it has nothing to do now specifically with certification, I'd like to mention two other collaborations that we have ongoing. We have different joint working groups with the OPAF, the Open Process Automation Forum. One group discussing jointly redundancy requirements. A second group working on the alignment of information models and also communication models. And a new group that will be launched next week, which is about offline engineering, the alignment of the AML modeling using automation ML. And in addition to that, we have a joint work ongoing with the 5G ASEA. As mentioned before, we are not only dealing with wired communication, but also with wireless. And we have in our joint work with 5G ASEA then different discussions, concepts that we elaborate to easily combine and integrate 5G into OPCUA devices and UAFX devices. This deals with the user plane, so how to transport the data over layer 3, layer 2, with IP-based communication, with Ethernet, even with TSN. But we also look into the control plane, how to manage and configure infrastructure components and end devices supporting 5G. Here the plan is to have a publication, a white paper ready later this year. So we're actively working on this. All right, so the next slides talk a little bit about what is coming next, what are the next steps. And certainly after now getting closer to having all the specs finalized on the controller-to-controller use case, we are now more concentrating on controller-to-device, including device-to-device. So even we already had the kickoff, the technical one, back in July last year, so already 1 year ago. We really do a careful and detailed handover of requirements to our technical working groups, really to ensure that they concentrate on our expectations, what the solution has to fulfill. And we have also been establishing the working group structure to then do the work for C2D and D2D. You see some of the work items that will be covered in this next project phase. It's about the parameterization, how controllers or even external tools are parameterizing the field devices. We need to work on some enhancements to networking, enhancements to the offline descriptor that we have established in our first project phase. We work on extended diagnosis, and certainly we are working on the different facets of what was previously usually named device profiles for the different device types like motion, instrumentation, I/O. So you see there is still a lot of work to do to also cover C2D. Nevertheless, we certainly started early to work on some of the facets that we understood are, let's say, quite complex and have a lot of different use cases. The best example is motion, because this working group was already launched in June 2022, so already 3 years ago. And here the idea was to rely on existing specifications. For motion, it was the agreement to use SIP Motion and Salcos, and then extend and change these concepts to fit to the modeling of OPCUA, to fit to the digitalization use cases. So this specification is already in work, and it's part of the C2D delivery in our second project phase. This first spec will include closed loop drives, sour drives, the open loop drives, typically named frequency converters, and some additional elements of motion that are listed here. I'm not going through the list. You can read that by yourself. A few weeks ago, we have in addition launched the Instrumentation Working Group, which is a collaboration with the Field Comp Group. We announced this joint working group, this collaborative working group, back in August last year during the AFEMA show. Since then, we have been developing requirements for instrumentation using OPCUA and UAFX. And in the kickoff, that is really good news, and it's exciting to see that we had more than 40 technical experts attending the kickoff to then start working on concrete concepts for the different instrumentation devices like flow meters, analyzers, transmitters, valves, and valve controllers. Important here is that this group is also considering how the existing companion specifications can be integrated. And you see here a key specification that is relevant for instrumentation, which is the PA-DIM specification. I think there is a presentation tomorrow on the PA-DIM that might be interesting for you. What I added here for your information is now the working group structure that we have been setting up for the second project phase. You see that we have the architecture working group as, so to say, the overall responsible group, because the architecture working group makes sure that all the different elements that are being specified fit to each other, also identifying common elements that are then becoming part of the infrastructure. So it's somehow a harmonization that is being done. We then have the three groups part of infrastructure. So this is the common foundation for UAFX devices, base facet, offline engineering, networking. We have the different groups working on specific facets, safety, motion, instrumentation. They have already been started, as you have heard. And we are very soon launching the I/O working group, which works on a facet for modular compact I/Os, probably in the next 4 to 6 weeks. Finally, we have two working groups dealing with prototyping, test development. So overall, 10 working groups that are really extremely busy. If you're interested to join, I have here all the chairpersons listed with their email address. But to get access to the SharePoint and to all the events, ideally you contact me to take off workload from our working group chairs. With that, I just have a few slides talking a little bit what we have been producing more, let's say, publicly in addition to the specifications. So we have been working on different multi-vendor demos, on controller to controller, on functional safety, and also including a 5G demonstration we did on some of the shows. Overall, we did 3 multi-vendor demos that we show in the different regions of the world. The recent one just celebrated premiere at the Smart Factory Automation World in Seoul in March this year. And for your information, I added here on the right-hand side all the contributing companies that provided prototypes and devices to showcase UAFX with regard to the different aspects. Finally, I have an overview on additional information. As I said, I just could give an overview, but if you need further information, more details on the technical level, you see here a list with different collateral, technical papers, brochures, flyers, and also included links to the recordings that we did last year on the digital days about OPCUA Field Exchange, where you find our technical experts explaining the solution approach and the different concepts. With that, I'd like to finish my update. I'd like to thank you for your attention.